Good evening, dear students. Yes. Shall we start?
Yes, ma'am.
Okay. So is the screen visible and am I audible properly?
Yes, ma'am.
Okay, fine. Okay. So in the last class, we have started with a new topic that is alcohol, phenols, and ethers. Okay. So we have seen first 13 questions. Okay. So in the last class, we have seen 13 questions. So we'll continue with the remaining questions. Okay. Fine. Okay. So six students have joined. Okay. Let us start. So this is the question. So you have a aldehyde. Okay. So this is the aldehyde. So this particular aldehyde, it reacts with your Grignard reagent, methyl magnesium bromide. Okay. And in the presence of ether, it will give you A. And further, it will undergo acid hydrolysis to give you B. So after undergoing this reaction, you have to find what is the IUPAC name of B. Okay. What is the IUPAC name of B? So yes, can you tell me? So this is a compound. So let me write the reaction. So CH3, okay, C double bond O H plus CH3 MgBr in the presence of ether. Okay, it will give you compound A. This compound A will further undergo hydrolysis to give you compound B. Yes, what will be the reaction? So what is the compound name? 1, 2, 3. Okay. So this is 2-methyl and it is aldehyde. Okay. So 3 carbons. So it is propane and aldehyde. You have to write it as propanol. Right. Propanol. So it is 2-methyl because at second position you have your substituent methyl group and 3 carbons. So propane and Al, right? In the presence of Grignard reagent, that is your methyl magnesium bromide, in the presence of ether, okay? So what will happen? Your carbonyl carbon, okay, it will undergo, so there will be substitution. So how it will be? So CH3, C, CH3, okay, H, then C. What will happen? Your, okay, your CH3 will attack, okay, from your CH3 MgBr and your MgBr will attack at this oxygen, okay, O Mg plus Br minus. Okay, so this is the O minus and Mg plus Br minus and H. So this is the product A. This is your product A. This further what it will undergo? It will undergo acid hydrolysis. It will undergo acid hydrolysis and what it will give you product? So here what will happen? Your O MgBr will be converted into OH. Okay, because it is undergoing acid hydrolysis. So what it will be? So CH3, then COH, CH3 and H. Okay. Let us write the numbering. Let us give the numbering. So how many carbons are there? Now See the longest possible chain. So 1, 2, 3. One more possibility is 1, 2, 3, 4. Okay, by taking one of the side chain. So if I take this, so 1, 2, 3 and 4. So what is the, it is butane. Okay, butane. Now see the substituent, at third position you have methyl, right? So we will write 3 methyl, methyl, then what is the parent carbon? Parent chain is butane, right? So it is butane. Then at second position, what you have? You have a alcohol. So it will be 2 O all, right? 2 all. So it is 3 methyl butane 2 all, right? 3 methyl butane 2 all. So this is the IUPAC name. So which is the answer? Okay, so I have got here three answers. Mm, Lubna has answered it as A. Okay. Shivaruni has answered it as A. Okay, yes. So A is the correct answer. So 3-methyl butane 2 all. Right. 3-methyl butane 2 all is the answer. Okay. I hope it is clear. Okay. Yes. Okay, fine. Let us go for the next one. Okay. So this is a type of addition reaction which we have seen. Let us go for the next one. So again, a reaction. Okay. You have a phenol. Okay, phenol. It is undergoing benzylation. Okay, C6H5COCl. So that is your benzyl chloride is there. So this is your benzyl chloride, C double bond O Cl. Okay, and then what you are going to get? Acetyl this in the presence of a base. Okay, you are going to get what? You are going to so it will undergo benzylation. First is a benzylation. Okay, first step. In the presence of what? There is a base. Okay, base can be your NaOH, KOH, any base. Okay, it will give you a product X. So phenol first will undergo benzylation. Okay, and then what you are going to get? You are going to get X. Okay, and that product further you are going to do nitration. How nitration occurs, students? How nitration takes place in the presence of concentrated HNO3 plus concentrated H2SO4. Okay, concentrated HNO3 and concentrated H2SO4. So this is called as what? It is called as nitrating mixture. Okay, it is called as nitrating mixture. So what is nitrating mixture? Concentrated HNO3 plus concentrated H2SO4. So by using that nitration mixture, we are going to get product Y, which is a major product. Now you have to tell what is Y. Okay, they have asked what is Y. So Y can be what is Y? So these are the four options. Okay, let us see what are the options. So these are the four options. Okay, fine. Let us write the reaction and see what we are going to get the product. Okay, let us see what we are going to get the product. Okay, fine. So I'll write the reaction. Okay, already I have got some 5 responses. Let us see. Mm, Lubna has answered it as D. Niharika has answered it as D. Kanaya has answered it as B. Amulya has answered it as B. Okay, fine. Okay, I have already got the answers. Okay, let me write. Okay, let me. Where the screen went? Okay. Hmm. Fine. So I'll write the reaction now. So what is the first step? Phenol is there. Okay. So let me write here. Phenol is there. So this phenol, okay, it is undergoing benzylation. Okay. It will undergo benzylation. Uh, this benzylation, benzoyl chloride. Okay. You have a benzoyl chloride. In the presence of a base. So I'll write here, I'll not write, so this is what is this process called as benzylation. So when you are undergoing benzylation in the presence of C6H5C double bond O Cl, so what will happen? Your hydrogen, okay, hydrogen will be replaced by the positive part of your benzyl chloride. That is O, okay, O, C double bond O, C6H5. Okay, so what will happen? So this is the what you are going to get. You are going to get a phenyl benzoate. What is the product? It is a phenyl benzoate. So this is your product X. This is your product X. Now further, what it is undergoing? Nitration. I said you what is a nitrating mixture. Okay, so it is undergoing nitration, that is concentrated H2SO4 and concentrated HNO3. So what I am going to get? What I am going to get? I am going to get a what? At para position, we know in nitration, what is our electrophile? It is nitro group, NO2 group, right? So nitro group, so it is a, so what will happen to nitro group? Where it will attach? Where it will attach nitro group? What type of group it is? It is an electron withdrawing group. So it is a para directing, ortho para directing. So when you see ortho and para, para is the major product. You get both the products. After doing nitration, you get both the products, ortho products also and nitro product also. But which is major? They have asked why is a major product. So it is a para substituted. So it is what? Para substituted. So at your para position, you have a nitro group. Okay. So this is the compound. So this is the compound. So which is the option? Nitro CO C double bond. It is OC OOC C6H5. Okay. And option number A. Option number A. So option number A. Can you hear me now? Okay. Speakers. Okay, fine. I'll go it. Okay, so again one time I'll repeat. So what we are doing, we have a phenol, we are going to do benzylation. How we are doing benzylation? By using a benzoyl chloride, that is C6H5 C double bond O Cl. So what will happen? Your positive part, okay, so this your C6H5 C plus and Cl minus. So your this part, okay, this will go and attach, okay, your H will be replaced by that. Okay, and you are going to get phenyl benzoate. What you are going to get? Phenyl benzoate. Now this phenyl benzoate, what you are going to get further? This is a X, product X. Now on this, we are going to do nitration. We know what is nitrating mixture. Okay, and in nitration, nitro group is the electrophile. Okay, nitro group is the electrophile and it is a electron withdrawing group. And when nitration occurs, two products are formed. It is a ortho para directing group. So at ortho and para position, it will attack. But what they have asked why product is a major product. So in between ortho and para, para products are more this what stable, or you can say they give you a major product. So our product is this. Okay, so option number A is the answer. So C6H5, C double bond O, NO2. Okay, so this is the para nitro. So it is 4 nitro. So because 1, 2, 3, 4. So it is 4 nitro. Then you have phenyl benzoate. So 4 nitro phenol benzoate is the name of this compound. Okay, so which is a major compound. I hope it is clear now. Yes, is it clear? Okay, so let us go for the next one. Okay. Next question. 16th question. 0.44 grams of 0.44 grams of monohydric alcohol when added to methyl magnesium iodide in ether liberates at STP 112 centimeter cube of methane. With PCC, the same alcohol forms a carbonyl compound that answers silver mirror test. The monohydric alcohol is. So they have asked which is the monohydric alcohol. Okay. So there is a 0.44 grams of monohydric alcohol when you are reacting. So you have a alcohol. Okay, and this alcohol, when you react it with methyl magnesium iodide, okay, we react with methyl magnesium iodide in the presence of ether. Okay, so it is liberating what? It is liberating methane. Okay, and with PCC, the same alcohol. So the same alcohol with PCC. So this is a your oxidizing agent. The same alcohol is forming what? It is forming a carbonyl compound. Okay, it is forming a carbonyl compound, and this carbonyl compound, it is answering what? It is answering a silver mirror test. Okay, silver mirror test. So they have asked which is this alcohol. So we have to find which is this alcohol. Okay, now so if you are having a alcohol and it is reacting with methyl magnesium iodide, okay, so what it is forming? It is forming a methane. Okay, and what will be the other products? So MgI and OR. Okay, because yes, OR, because you have a alcohol. So this is the product. This is the first step. So alcohol, we are reacting with methyl magnesium iodide. So this is our first. Okay, this is our first line. So alcohol, when we are reacting with methyl magnesium iodide in the presence of ether, it is giving you methane. It is giving you methane. Okay, and this methane, how much liberated? It is 112 per centimeter cube of methane, and the alcohol amount is 0.44 grams. And how much it is? 112 centimeter cube of this much it is giving. So if the same alcohol, when you are reacting with this PCC, you are getting a carbonyl compound, and that is giving you a silver mirror test. Okay, now 1 mole. So 1 mole, we have to find what is 1 mole. Okay, how much grams? So at STP, what is the standard? This, it is 22,000 volume. It is 22,400 per centimeter cube. Right. For 0.44 grams, it is giving you 112 centimeter cube. Okay, so how much is 1 mole? For 1 mole, it should give 22,400 centimeter cube at STP. Okay, so how you are going to find the mass? Just do cross multiplication. Okay, so it will be 0.44 into 22,400 divided by 112. Do it. How much it will be? 0.44 into 22,400. So 0.44 into 22,400 divided by 112. So 88. Okay, so it is 88 grams. It is 88 grams. Okay, so here alcohol when it is reacting with a PCC. Okay, alcohol when it is reacting with PCC, what it is giving? It is giving you a carbonyl compound. Okay, and this carbonyl compound will answer what? Silver mirror test. So silver mirror test is answered by what? Silver mirror test is only answered by the aldehydes, right? Silver mirror test is only answered by what? It is answered by aldehydes. Now, when we know that aldehydes, so aldehydes are formed when you have a primary alcohol, right? So aldehydes are formed when PCC is what? PCC is a good oxidizing agent, right? We know that PCC is a good oxidizing agent. So for oxidizing the alcohol to aldehyde, what should be the aldehyde? Alcohol should be a primary alcohol. What it should be? It should be a primary alcohol. So alcohol should be, here I'll write, it should be a primary alcohol. Okay, so when primary alcohol reacts with PCC, which is a good oxidizing agent, okay, it will give you a aldehyde, and aldehyde only reacts with what? Silver mirror test. Okay, so your answer, so just see which is the primary alcohol among the options. So these are the 4 options. Okay, just see which is the. So first one is your secondary alcohol. Second one is your primary alcohol. Okay, and here also is your primary alcohol. So yes, so these are the 4 options. So your option will be either B or D. Okay. So B or D. Now, so this is a primary alcohol. This is a primary alcohol. This is a secondary alcohol. This is a secondary alcohol. But we have found what? The monohydric alcohol mass is 88 grams. So find out among these two which is having 88 mass. Carbon is 12, hydrogen is 1 and oxygen is 16. Put the masses and check which is having 88. So either B or D. Okay. So, yes. So, many have answered it as B. Yes. And B is the correct answer. So, yes, B is the correct answer. So, if you put the masses, okay, and if you find out, so 88 gram is the mass of your primary alcohol. Okay. So, this is the option B. Option B is the correct answer. Fine. Let us go for the next one. Arrange the following compounds in the arrange the following compounds in the increasing order of their acidic strength. So first option is paranitrophenol, second is metacresol, third one is phenol, and fourth one is metachlorophenol. Yes, we have already seen such based on the acidic strength. So please tell me. Yes, what is the answer? Arrange the following in the increasing order of their. So this is nitrophenol. Then is your metacresol. Metacresol. This is first one. This is second one. Then third one is phenol. And fourth one is metachlorophenol. Okay, I'm writing the structures. So accordingly, you tell me. Yes. So nitro group is an electron withdrawing group. This your methyl group is an electron donating group. So which is the answer? You have to tell electron increasing order of their acidic strength. Okay. Sri Varuni, Lubna, Kanaya has answered it as D. Amulya has answered it as D. Sushant Gowda has also answered it as D. So when you see the nitro group, okay, nitro group will show both. Okay, it is an electron withdrawing group. Okay, it will withdraw the electron towards itself. So it is showing both. That is your minus R effect and minus I effect also. Okay, but here your minus R effect, okay, it is more because of the electron density. Okay, because of the electron density. So due to stronger, what it will do, it is electron, because of the electron withdrawing nature. Okay, it will withdraw the electron towards itself. So what will happen? The phenoxide ion, okay, it will be more stabilized. So when you see the nitrophenol, so nitrophenol is more acidic than your phenol. So when you see nitrophenol, so nitrophenol is more acidic than your phenol. Okay. Now, when you see methyl group, what a methyl group will do? It will destabilize. Okay, it will not stabilize the phenoxide ion. It will destabilize the phenoxide ion. And methyl group will show what? It will show plus I effect. Okay, it will show plus I effect, and also methyl groups, they will show hyperconjugation effect. Okay, no bond resonance effect, that is called as no bond resonance effect, that is hyperconjugation. Okay, so metacresol, when you see metacresol, so this is a weaker acid, okay, than your phenol. So this is what? This is a weaker acid than your phenol. So this will come first. So when you compare your this, so first will be your metacresol. First will be a metacresol. Now, when you see chlorine as compared to your phenol, chlorine. So chlorine will show both type of effect. It will show plus R effect also, and it will show minus I effect. But minus I effect will be more, okay, because it is an electron withdrawing group. So because of that, it will withdraw the electron towards itself. So what will happen? So your this your chlorophenol, it is more acidic. Okay, this is more acidic than the phenol. Okay, it is more acidic than the phenol. So your first will be your what will come first? First will be your metacresol. Metacresol, then will be your phenol. Okay. Then will be your metachlorophenol, and then will be your metanitrophenol. Okay, so it is option number D. Yes, option number D is the answer. So when you arrange it in the increasing strength, okay, so the weakest is your this, then will be your phenol, okay, then will be your metachlorophenol, and then will be your nitro, because this is the it is having more acidic strength. Okay, the most acidic strength which is present is in the, because the electron density is very less. Because why? Nitro group is a electron withdrawing group, so the electron density in the benzene is very less. Okay, so yes, option number D is the correct answer. So yes, many have answered. Sanjeevni, Preeti have also answered it as D. Very good. Okay, so very important question based on acidic strength. Okay, so they may ask you increasing order, decreasing order. They'll give you a set of compounds, and they will tell you to either arrange it in the increasing order or decreasing order of their acidic strength. Okay, let us go for the next one. In the reaction, okay, there is a reaction. What is the reaction? Ethanol is there. Okay, it is reacting with ethanol in the presence of PCl5. It is giving you X. Okay. Further, this X reacts with alcoholic KOH to give you Y. Okay, this Y reacts with H2SO4 in the presence of room temperature. Okay, and water and heat will give you Y. Sorry, Z. Okay, so what is the product Z? They have asked you what is the product Z. So these are the four options. So let us see the reactions. Okay, so first is what? First is the ethanol. So let us write ethanol CH3 CH2 OH. Right, ethanol. Now this ethanol in the presence of what? PCl5. What is PCl5? Phosphorus pentachloride. Okay, phosphorus pentachloride. Now what will happen when you are having a phosphorus pentachloride? Your OH will be replaced by Cl. Your OH will be replaced by Cl. So it will be CH3, CH2, Cl. Okay, OH group is replaced by Cl. Now further, what we are doing? We are treating it with alcoholic KOH. Okay, we are treating it with what? Alcoholic KOH. Now what we are going to do? When you have when you have a alkyl halide, and when you are doing a this alcoholic KOH with the alcoholic KOH, this is a dehydrohalogenating agent. Okay, it is a dehydrohalogenating agent. So when you have a dehydrohalogenating agent, okay, when you have a dehydrohalogenating agent, so there will be removal of one hydrogen and one halide. Okay, so when hydrogen and one halide will go, so what we are left with? We are left with what? We are left with a this what? We are left with a alkene. Okay, that is our ethene. So this is a ethene. This is a ethene. So this is what? Ethyl chloride. This is ethyl chloride. Okay, and this is what? Ethanol or ethyl alcohol. Okay, so ethanol, we are reacting with PCl5. So your OH is replaced by Cl. Further, we are reacting it with alcoholic OH, which is a dehydrohalogenating agent. Dehydrohalogenating agent means there is a removal of hydrogen halide. So your X is our chlorine. So after removing hydrogen and your chlorine, you are going to get a ethene. Now this ethene is what? This is Y. This is our X. Okay. Further, we are reacting it with what? We are reacting it with H2SO4. Okay. At room temperature and water, and we are going to heat it. Okay. H2SO4 at room temperature, water, and we are going to heat it. So what will happen again? What we are doing? Again, we are going to get our CH3, CH2OH. Okay. So it is a hydrating agent. H2SO4 in the presence of water, this is what? It is a hydrating agent. It is providing water molecule. So it is going to get what? You are going to get Z. So what is our Z? Z is our, which is option? It is D. Are you getting the same? Are you getting D? Okay. Lubna has answered it as D. Shri Varuni has answered it as D. Preeti has answered it as D. Sanjeevni has answered it as D. Okay, yes. Kanaya has answered it as D. So yes, so D is the answer. Understood? So you have to follow the steps. On the arrow mark, whatever is given. Okay, so what is the role of that reagent? So that you need to know. PCl5. Okay, PCl5 in that chlorine is there. So chlorine is a replaceable this. Okay, so your OH is replaced by your chlorine. So we get ethyl chloride. Okay, then alcoholic KOH. What is the role of alcoholic KOH? It is a dehydrohalogenating agent. So what it does, it removes a hydrogen halide. Okay, so one hydrogen, one halide goes, and what it forms? It forms a alkene. So the resulting alkene here is a ethene. So this ethene, further we are reacting it with H2SO4 at room temperature. Okay, in the presence of water, we are heating it. So this is a this is a hydrating agent. H2SO4 is a hydrating agent. We are going to get back again what? We are going to get back again our ethanol. So here, which is the answer? Option number D. Option number D is the answer. Okay, I hope everybody has got it. Okay, let us go for the next one. Which of the following compounds is more acidic? Which of the following compounds is more acidic? So these are the four options. These are the four options. So which are the which of the following is more acidic? Shri Varuni has answered it as C. So we have to see the nature of the groups which are present. So this is a phenol. Okay. So your nitro group is there. Now we know that because of the this what nitro group is the electron withdrawing group. Okay. And when we see a nitro group, so when the nitro group is placed at ortho or para position, okay, it is said to be most acidic. Okay, it is said to be more acidic. So option number C. So here you can see it is at ortho position. Okay, so option number C is the answer. So why? Because nitro group is an electron withdrawing group, and because of this electron withdrawing nature. Okay, so orthonitrophenol is most acidic among this following. Okay, so this is the electron donating group. So not possible. Okay, it is the least acidic. So they have asked most this acidic. Okay, so it is option number C. Yes, Kanhaiya, Amulya, Lubna have answered. Baby has answered. Very good. Okay. Yes, so option number C is the correct answer. So let us go for the next one. The reaction which involves dichlorocarbene as an electrophile is. The reaction which involves dichlorocarbene as an electrophile is A. Rimmer-Timmer reaction, B. Kolbe's reaction, C. Friedel-Crafts acylation, and D. Fittig's reaction. So dichlorocarbene. Dichlorocarbene. Yes. Which is the reaction which involves the formation of dichlorocarbene? This is a dichlorocarbene. Okay, this is a dichlorocarbene. So in which reaction we are making use of dichlorocarbene? Shri Varuni has answered it as A. Lubna has answered it as A. Yes, A is the correct answer. Okay, in Rimmer-Timmer reaction. So what is Rimmer-Timmer reaction? We will just understand what is Rimmer-Timmer reaction. So we have a phenol. So Rimmer-Timmer reaction is done on phenol. So phenol, we are reacting it with chloroform, that is CaCl3, in the presence of NaOH. Okay, NaOH at a temperature of 340 Kelvin. What we are going to get? We are going to get your hydrogen. Your hydrogen is replaced by, okay, so O minus Na plus, so Na plus, okay. And we are going to get what? We are going to get a aldehyde at ortho position. Then further we are reacting it with dilute HCl, okay, dilute HCl. Then what we are going to get? We are going to get a benzaldehyde, okay. So it is a salicylaldehyde. So this is a salicylaldehyde. So with dilute HCl, there is NaCl, removal of NaCl. Here also there is removal of NaCl. So what we are going to get? We are going to get a 2-hydroxy benzaldehyde. Okay. So yes. So which is the answer? A. A is the answer. Okay. So CaCl3 in the presence of OH minus. Okay. What we are going to get? We are going to get a carbene ion, dicarbene ion. So this is the formation of dicarbene ion. Okay. Yes. So option number A is the correct answer. So Rimmer-Timmer reaction. So who all have answered it as A? Yes. Very good. Amulya has also answered. Very good. Okay. Let us go for the next one. So these are the name reaction, very important reaction for theory, as well as like this applicative type of questions they are asked in your CET. Okay, let us go for the next one. Ethanol is converted into ethoxyethane. So how ethanol is converted into ethoxyethane? A, by heating excess of ethanol with concentrated H2SO4 at 140 degrees Celsius. B, by heating ethanol with excess of concentrated H2SO4 at 443 Kelvin. C, by treating with concentrated H2SO4 at room temperature. D, by treating with concentrated H2SO4 at 273 Kelvin. So how is ethanol converted into this? Okay. Sushant has answered it as B. Preeti has answered it as A. So I'll write the reaction. Ethanol is what? CH3, CH2OH. Okay, ethanol in the presence of what is converted into ethoxyethane. What is ethoxyethane? Ethoxyethane means ethoxy group at one side. Okay, ethoxyethane. So it is a ether. So alcohol, how you can convert it into ether? By treating it with concentrated H2SO4. Right. So by treating it with concentrated H2SO4 at 140 degrees Celsius. So option number A is the answer. Okay, with option number A. So that is when you are treating ethanol in the presence of concentrated H2SO4 at 140 degrees Celsius. Okay, you are going to get what? Ethoxy ether. So option number A is the answer. Kanaya, Shrivaruni, Lubna. Yes, your answers are correct. It is A. Okay, fine. Next question. One more question based on acidity. Try this. Which of the following orders is true regarding the acidic nature of phenol? What is true regarding the acidic? So there are three. One is your phenol. Another is your orthocresol. And another is your orthonitrophenol. Okay. Can you tell me what is the order? What is the order which is less acidic? This is the electron donating group. Electron donating group is what? Electron density will be more. Okay. So acidic, right? So this is less acidic. Electron donating withdrawing group is nitro group. Electron withdrawing group is nitro group. So what will happen? The electron density is less in the benzene ring. In the ring, the electron density is less. So because of that, what will happen to acidic strength? Acidic strength will be more as compared to phenol. So how you are going to arrange now? So orthocresol will be less than your phenol and then your orthonitrophenol. So option number B or option number B. Yes, option number B. So who all are telling it as option number B? Lubna and Sri Varuni. Okay, understood? So what is the role of electron donating group? Electron donating group will give this. Okay, it will give the electron to the this. Okay, benzene ring. So what will happen to the electron density? Electron density will be more. If electron density is more, what will happen to acidic strength? Acidic strength will be less. What is the role of electron withdrawing group? It will withdraw the electron density from the benzene ring. So what will happen to electron density? It will be less. So as electron density is less, what will happen to acidic strength? It will be more as compared to phenol. So first is your that is orthocresol is less acidic than your phenol, and then is your orthonitrophenol. So as the acidic strength is more in orthonitrophenol and it is less in orthocresol. Okay, so option number B is the answer. So who all have answered it as option number B? Yes, your answers are correct. Very good. Okay, let us go for the next one. Which of the following cannot be used to oxidize primary alcohol to aldehydes? So for conversion of primary alcohols to aldehydes, okay, which is the oxidizing agent which cannot be used? First one is CrO3 in your chromic acid in anhydrous medium, B pyridinium chlorochromate, that is PCC, and C is KMNO4 in acidic medium, and D is heating in presence of copper at 73 Kelvin. Preeti has answered it as C. Others? Cannot be used to oxidize primary alcohols to aldehyde. Which of the following cannot be used? So when you are converting your primary alcohols to aldehydes, okay, so these C in acidic medium it cannot be done. So if you are using KMNO4 in acidic medium, that is in the presence of H plus ions, it will direct oxidize alcohol to carboxylic acid. Okay, this is not possible. So from alcohol directly it is converted to carboxylic acid. You can convert alcohol to aldehyde in the presence of alkaline KMnO4, or you can use aqueous KMnO4. Okay. By this using this you can convert your alcohol to aldehyde, but by using acidic KMnO4 you are directly converting the alcohol into your carboxylic acid. So by using KMnO4 in acidic medium you cannot do the conversion of alcohols to aldehyde. So option number is C. Okay, option number C is the answer. Yes, Shri Varuni, Lubna have answered, Kanaya has answered, Preeti has answered. Okay, very good. So option number C is the correct answer. Okay. Let us go for the next one. The products formed during the following reaction are. What are the products formed in the following reaction? So this is the reaction. So you have a CH3C, CH3, CH3, O, CH3 plus HI. So this is a compound. Okay. So what is the compound? So you can see it is a tertiary compound. Okay. There is a tertiary group. So it is a tertiary. Number of carbons are 4. Okay. So it is a butyl. Okay. One is a butyl group. Okay. One is a butyl group. Another is a methyl group. So it is a butyl methyl ether. So it is what? Butyl ethyl ether. So what is the compound? It is a butyl ethyl ether. Okay. So it is a ether. So across the ether linkage, okay, one is a methyl group, another is a butyl group. Fine. So by seeing the alphabet, so first your butyl will come and then your methyl will come. So tertiary butyl methyl ether. So in the presence of HI, okay, hydrogen iodide. So what you are going to get? You are going to get what? So one product will be your CH3, C double bond O, CH3, CH3I. Okay, and another will be your alcohol. Another will be your alcohol. So this is your tertiary butyl iodide, tertiary butyl iodide. Okay, and another is your methyl alcohol. Another is your methyl alcohol. So which is the answer? Which is option? So yes, option number A. So these are the 4 options. Okay, so these were the 4 options. So out of these 4 options, you can see that option number A is the correct answer. Yes, Lubna has answered, Preeti has answered, Shri Varuni has answered. Yes, so option number A, Kanaya has answered. Okay, so yes, option number A is the correct answer. So this is undergoing a SN1 mechanism. Okay, in haloalkanes, haloarenes, we have studied what is SN1 mechanism. Right, so it undergoes a SN1 mechanism. Fine, let us go for the next one. Okay. Phenol can be distinguished from ethanol by the reagent. Phenol can be distinguished from ethanol by the reagent A. Bromine water, B. Sodium metal, C. Iron metal, and D. Chlorine water. Phenol, how it can be distinguished from ethanol by the reagent? So phenol, how it can be distinguished from ethanol by the reagent? So if you treat your phenol, okay, how it can be distinguished from ethanol is nothing but alcohol. So how it can be distinguished? This is phenol is what? It is a AROH. Okay, you have a aromatic ring. In alcohol, you have a ROH. That is, you have a aliphatic this. So how it can be distinguished? Okay, so phenol, if you treat it with bromine water, 3 moles of bromine, okay, bromine water, what you are going to get? You are going to get a tri-substituted bromo compound. Okay, that is the name is 2,4,6. So 1, 2, 3, 4, 5, and 6. So 2,4,6 tribromo phenol. Okay, you are going to get a white PPT. You are going to get what? You are going to get a white PPT. Now the same reaction with alcohol, okay, it does not give any reaction. Okay, with the same, with the bromine water, it does not give any PPT. Okay, no product is formed, no PPT is formed. So it is option number A. So how you can distinguish your alcohol and your phenol? That is by treating it with bromine water. Okay, by treating it with bromine water. So Kanaya, Lubna, Amulya, Shrivaruni has answered it correct. Okay, so yes. Option number A. So with the phenol, it is giving a test with bromine water. It is forming a white PPT. But with alcohol, it is not possible. Okay. There is no such reaction possible with alcohol. So this is a distinguishing test. So remember this distinguishing test. So it is with bromine water. So with bromine water, your phenol can give the test, but with your this, it won't give. Okay. Next question. When the vapors of tertiary butyl alcohol are passed through heated copper at 573 Kelvin, the product formed is, okay. So you have a tertiary butyl alcohol. So you have a tertiary butyl alcohol. So this is your tertiary butyl alcohol. So this tertiary butyl alcohol, you are reacting it with what? Copper in the presence of 573 Kelvin. So what it is? What is the role here? So what it is doing? It is a dehydrating agent. Okay, it is a dehydrating agent. So what it will remove? It will remove from here. Okay, I'll show you. So it will be CH2H. So what will happen here? Your okay, so this will there will be loss of your H2O. Okay, there will be loss of H2O. So what you are going to get? So CH3, C and CH3, and you are going to get a double bond. Okay, you are going to get a double bond. So this is the product. This is the product. So what it is? What is the name? So 1, 2, 3. So it is a 2-methyl, 2-methyl propene, 2-methyl propene. So just see which is the answer. 2-methyl propene. Option number C. So when you pass the vapors of tertiary butyl alcohol through heated copper, okay, what is the product from? 2-methyl propene. So there will be removal of water, dehydrating agent. Okay, fine. Next reaction. Acidic strength we have already seen, so let us leave. Next question is this, okay. The products X and Y in the following sequence are. So this is a test reaction given. Okay, you have a benzene ring. Okay, it is reacting it with a alkene. Okay, you have a propene. So you have a propene. Okay, in the presence of aluminum chloride, okay, and ether, you are going to heat, you are going to get X. Further, in the presence of O2, okay, you are going to, in the presence of, at a temperature of 130 degrees Celsius, you are going to go get Y. Then acid hydrolysis, heat it, you are going to get phenol plus Z. What is that? Which reaction is this? It is a cumene synthesis, right? Preparation of cumene synthesis. So what is the product? It is a acetone. So byproduct is very important. It is a acetone. So option number A is the answer. So first one, isopropyl benzene. Okay, so what is X? X is a isopropyl benzene. So what we are going to get here? We are going to get a isopropyl benzene. So that is CH3. Okay, so we are going to get isopropyl benzene. Then what is Y? Y is a cumene hydroperoxide. Y is what? Cumene hydroperoxide. So this is cumene hydroperoxide. This is Y. Then further, this is your phenol. This is your Y. This is your X. So acetone. So isopropyl benzene and acetone. Option number A is the answer. So who all have answered it A? Yes. Lubna, Amulya have answered it as A. Okay, very good. Fine. Let us go for the next one. Which of the following can be used to test the acidic nature of ethanol? So we can use what? For testing the acidic nature, sodium metal can be used. Okay, remember D option. Because when you take ethanol, okay, that is CH3, CH2, OH. So when you treat your ethanol with metal like sodium metal, you are going to get what? CH3, CH2O, Na. Okay, so plus hydrogen gases liberated. So there will be hydrogen liberation of hydrogen gas. So when hydrogen gas is liberated, so like this, the acidic nature is detected. Okay, so sodium metal. So sodium metal is the metal which can be used to detect the acidic nature of ethanol. So option number D is the answer. Option number D. Yes, Sri Varuni has answered it correct. Option number D is the answer. Okay, let us go for the next one. The steps involved in the conversion of propane to propane 1-all are in the order of. So what we are going to do, we are going to convert propane 2-all. So what is propane 2-all? So this is propane. So at 2 position, you have OH. So this to convert into propane 1-all. Okay, this is propane 1-all. So how you are going to convert? Okay, how you are going to convert? So first step is what? First reaction we are going to do. So we have to convert this into Cl. Okay, how we are going to convert it into Cl? By treating it with PCl5. So by treating it with PCl5, what we are going to get? We are going to get CH3, CH, CH3, Cl by treating it with PCl5. Now further what we are going to do? We want to remove this Cl now. So if we use alcoholic KOH, there is a removal of hydrogen halide. So what we are going to get? CH3, CH double bond CH3. CH2. Okay, so this is the CH2. So what is this? So further, what we are going to go do? So further, if we do hydroboration, okay, further if we do hydroboration, that is when we do oxidation on this, what will happen? Your water, okay, hydroboration means what? You are adding water molecule. So what we are going to do? CH3, CH2, CH2OH. Okay, so we are adding water. Okay, we are doing a hydration. So we are going to get this. So what we are doing? It is option number B. Okay, option number B is the correct answer. So option number B is the correct answer. Yes. Okay. So what we have done? So we have propane 2-all. We have treated with PCl5. When you treat it with PCl5, your OH is replaced by Cl. Okay, further what is happening? The Cl, I want to remove out the Cl. Okay, so how we can remove Cl and one hydrogen by using alcoholic KOH because it is a hydrogenating agent. So by this we can convert it into a alkene. Further, that alkene can be converted into primary alcohol by doing hydroboration because we are adding water molecule. So it is option number B. Yes, Kanaya and Amulya Lubna have answered. Very good. Okay. So, yes, so these were some of the questions from your chapter, alcohols, phenols and ethers. Okay. Any doubts in today's session? Okay, fine. Did they complete in your college with aldehyde, ketones and carboxylic acid? Okay, fine. So let me see. Okay, in the next class, I'll be starting with that chapter. Fine. Okay. So I hope today's session is clear. Okay. So if you get any more questions, so please try to solve more questions on this. Okay. Remember all the name reactions. Okay. What are the reagents used? So these all things you have to keep in mind. Okay. Fine. So by this, I shall end the session here. Okay, we'll meet in the next class. Thank you.